back, students. Again, this is Eric here with Exclusive Tutoring SD. We're just going through the 2022 free response questions that are available on our AP Central Calculus AB, okay? So what I'm doing here is when you go in here, it's in here, free response questions, scoring guidelines. We have these pulled up so that we can double check our work, okay? We've already done number 1, number 2. So if you haven't checked those out yet, go ahead and go look through the playlist and you should find them in here as well. Otherwise, go to the channel, which is, Exclusive Tutoring SD, and you can go ahead and find those questions and how to solve them. Okay, next, we go into this part where no calculators are allowed. So keep in mind, the past one, you were able to use the calculator to calculate a couple of these situations, put them directly in and get your answer, as long as you showed had your answers shown, or what you input into the calculator shown in terms of the integral or derivative. They'll give you those full points. Keep in mind, each of these is usually worth more than just 1 point. There will be additional criteria that they're looking for the full full point value. That's how they give you the 1 to 5 range on your AP test. Now this one, number 3 right here, is the first one in our no calculator section. Now realize this, it's not going to be too terrible. So in this one, you can see it is a semicircle down here. You have a slope of 1 and 1, and then a slope of -1 here. And very likely, when I see these types of equations, I very quickly think, okay, they're going to ask for area under the curve here. They're going to ask for area under the curve here. And depending on what they're asking for, from whatever additional information they give us, we can figure those numbers out. It's not too bad. So f is a differentiable function with f of 4 is equal to 3. So we definitely need that, all right? We're going to use that. F of 4 is equal to 3. On the interval of 0 to 7, which we can see, the graph of the derivative the derivative of f, consists of a semicircle and 2 line segments, as shown in the figure above. Okay, so find f of 0 and find f of 5. Well, what that means is if this is the derivative, then we also have a starting point. So you can almost think of that kind of as C, or, sort of a C. But a number that we're actually starting from because of 4, okay? So f of 4, if I want this 0 value, we're going to have to go backwards, right? If we want the 5, we have to go forwards. The 5 is easy. 5 right here, we're going to go ahead, and on that, we're going to very quickly, if you think about this triangle that exists over here, that triangle in there is a 1 by 1 and then cut in half, right? So that's a half area. So what we're doing to find f of 5 is we're going to go ahead and take f of 4, and then we're going to add the area under the curve from 4 to 5 of this function dx. Okay? And that's what we did. So here it would equal 3 plus a half, which is 3.5. On the other hand, we got to remember, if we're going backwards from the 4, we're going to have to subtract, okay? So f of 4, if I want f of 0, f of 4 minus the integral of 0 to 4, right? You could also think of plus 4 to 0, but that's kind of a more advanced thought process. 0 to 4, f prime of, and then dx. Okay. And as a result, what we have here is we have a semicircle, which is half of pi r squared. This r here is a 2, so we're going to make that r squared a 4. 4 divided by 2, that's equal to 2 pi. So we're going to say the answer for this is 3 minus 2 pi. Okay. Real quick here, like I'd said, 4 to 0 or so. We also have to realize that that's right here. This is a negative value, right? It's underneath. So when we subtract that, it's actually a positive 3 plus 2 pi. Okay. So in here, what we have is the equation for both of them. That's worth a point. And finding the value, this 3.5 or 7 over 2, and the 3 plus 2 pi, which we both have. Okay. Total for this is 3 total points. Okay. All right. B. Let the coordinates of all points of inflection on the graph for this. So what are the points of inflection? Well, if we have f, this is the derivative, right? And then below, if you found another derivative, this is the one that when this is equal to 0 is considered the point of inflection. So what that means is wherever this graph has a slope of 0, that slope of 0 would be at 2 here because it's turning around, and at 6 here because it's turning around. Now, technically, in this situation, this would be a slope of 1, and then it would have a cusp point and it would jump down there. So 6 isn't exactly going to give you a point of inflection in a technicality. But let's go ahead and look here at their answers here. Okay, so has a point of inflection at 2 and 6, right? Because it changes from decreasing to increasing and increasing to decreasing. Okay, so that would be, so what we would look, what would my response have given us? A response of only 1 earns 1 of the 2 points. Okay. To earn the second point, must use a correct reasoning. Okay, signs in the slopes, local extrema, etc. But you see a little bit here, they do get a bit technical. Second point cannot be earned by the use of vague or undefined terms such as it or the function or the derivative. Okay, let's go back. C. Would the function defined be this function? Okay, on what intervals, if any, is g decreasing for this? Okay, now we actually have to go find the derivative. Right, this derivative is just going to add an additional -1 to this. Okay, so everything's going to shift down. On what intervals is g decreasing? Well, decreasing meaning that the values are negative. Where are the values negative? Well, technically, if we're shifting everything, we're going to go down by 1 here. So that means that all the negative values are up through 4. Okay, that makes sense? So here, interval, decreasing on the interval, right? Oh, well, they're going to include, yeah, negative values up through 5. So technically, the answer would be, and not include 5 when you consider that, right? These are all the negative values for that g. For the function defined in part C, find the absolute minimum value on the interval. Justify your answer. Well, the minimum for this interval is going to be, because you're going to continue adding these negative areas all the way up to here. By the time you hit 5, that'll be when you hit the most negative, and then you start adding positives here. So 5 is going to be where that starts to be the most, that's going to be the most negative. All right, absolute minimum at 5. Okay, and we can show it with the justification as well, how it changes, how it is all the negative values and negative area under the curve added together, therefore gives you that. Okay. All right. Hope that was helpful. We're going to continue going through these before the test comes up in May. So keep, stay tuned. I'm going to help you guys understand how to maximize your points here for the AP test. All right. Talk to you guys soon.